short survey. There are 6 general questions that we will go through together over the next 4 or 5 minutes. Please open the following link in your browser or with your cell phone and enter the code. And I switch to the Mentimeter. Which Ethernet-based field bus do you already use? Okay. F19. Interesting. Currently I have 50% answers. Then I switch to the second question. How would you rate your acknowledgement of Profinet technology before this workshop? Oh. Okay. This is a good question for the first part, the basics of Profinet.
Just for everyone who joining right now, you can find the code right above the screen Alex is sharing. There where stands join@menti.com, use code 8260. You can find it there. So you can join right now too and have a vote.
Yeah. Here's the address in the top line. Menti.com and the code. Thank you. Yeah. Okay. Then I go to the next question. Who you are from? In which field do you or would you like to use Profinet in the future? From automation, industry, production, whatever. Okay. Interesting. Okay. Then we can go to the next question. It's not for everyone, I know. When you are a vendor, what's your interest in? Okay. Okay. Developer and vendors. Not vendors, that's okay. Okay, then 5 of 6. Which service is most interesting for you? Controller, devices, sensors is in German. Okay. Communications, internal or the outside. Internal. Okay. And the last question. Last question is not really a question. This is, what's your interesting point? Is it I don't know, SRCI? Is this an ASIC? What is your interesting? Basics. That's cool. And certification. Certification is, by the way, an additional workshop in June. Protocol. APL, okay. For APL, we have only also a workshop in June. Okay. New trends in Profinet. This is a part from Mirko. Okay. Encryption. Diagnostic. Okay. Cool. Then I say thank you. The Menti is open in the background. I move this to the side, and you can use this by the side. Okay. Now I would like to briefly explain what the PI organization is. The PI organization is an association of vendors, manufacturers, and their customers. We also have worldwide competence centers for training, testing, certification, and support. And we maintain collaborations with other organizations, for example, OPC Foundation or Namur. The PNO is the German partner of the PI and your organizer for today. What we do, but what do we do? We discuss the global standards for technologies. We support providers with the integration of Profinet and the following certification, and we present technologies at trade fairs and organize online presence workshops. And the goal is that we make the technology understandable for everyone. Today I'm supported by very special experts. By the way, the experts usually work for their companies and support the PI organization in activities and also in as presenters and referencing. The agenda. We have split the agenda in 3 blocks. The first block is the section on the basics of Profinet. In the second and third section is the focus on the development and the hardware and software. In the end is the development. At the end of the development process, it's a short overview of our certification. I know 10 minutes is not many for certification, but in June we have a completely workshop over 2 hours over certification, and I think this is more time for this part. Then we always have time for questions at the end of each questions. At this point, it should also be say once again, the webinar is free for charge. The reason for this are our sponsors. This is also the reason we will show marketing videos from them. We have here 2 blocks for them. And yeah, who are the sponsors? The sponsors are semiconductor and chip manufacturers for controllers and devices, also cables and connectors, and developers for software and for users test and software for everyone. I don't know. We have many software for this. In other words, this is software for and hardware for Profinet communication. Okay, and sponsors for today, we have here Analog Devices, Deutschmann and Hilscher. And over the link here in the top, you have the site of the Profibus or the PI organization with more information and the link to the main pages of the sponsors. Other sponsors for today is HMS, Molex Port, Siemens and TMG. Okay, and then moderators and references. Mirko here is the specialist for TSN and ecosystem of Profinet with many years of experience. Then we have Thomas. Thomas is also a very specialist for, and especially for Profidrive and Profisafe. Then we have Christian. Christian is hardware engineer, many years experience here. Then Nico. Nico is electronic engineer and from the semiconductor. Then we have Reich. Reich is not only a specialist for certification, he is also the head of a PI test lab. Then we have Emilia. Emilia writing comments here in the chat, and is our backbone from the organization for the documents, registrations, and many more. And finally, myself. I have many little to-dos here. I go to trade fairs, I'm an organizer of workshops, and yeah. Good. Then general thing, you can write us comments during the presentation in the chat, and we will sort them and include in there in the Q&A sessions. When we cannot answer all your questions online, don't worry. All question and answer we will also make available into the documentation share. So, and now I will hand over to Mirko and the presentations for Profinet ecosystem and Profinet basics. Mirko.
Hi, good morning also from my side. So now I will try to share. I need to be moderator first. So. So. Good. That's me. Good. I hope you can see my slides. Yeah, you can. Good. Okay. Let's start with the first round here. Profinet ecosystem, and this should be now a little introduction into the Profinet topic itself. So why are we doing this? Why is it also useful for you as a vendor to participate on that ecosystem, and why is it necessary to develop devices? Okay, itself, the Profinet standard. It's defined in the Profinet user organization, which is a vendor-independent organization, not driven by just one company. We are collaborating, or let's say organized. We have more than 1,500 companies in there, and we are driving together this open standard. And here are many different companies all together working on that. So that means, in the end, this is not just one company that is defining here something. This is vendor independent, and so we are looking also for interoperability. In itself, Profinet is based on standard Ethernet. More to this later. But because of it is Ethernet based, we can use this, and also to change something in the paradigms that are already known from the world. The automation pyramid, everybody knows. Since 20 years, we are playing for this automation pyramid, where we have the sensor communication, sensor level somewhere down in the field, then we go up to the PLC level, where we collect all these sensors, have the user program. Afterwards, we have the HMI, and somewhere then on the top, let's say the company network, where all of this information is aggregated to. But what we see in the last years with the digitalization, with Industry 4.0, or however these buzzwords are called, this automation pyramid dissolves, and it is somewhere where we call it also a converged network. And in the end, Profinet is the foundation for this converged network since more than 20 years. Since more than 20 years, we have Profinet, we have standard Ethernet working here on, and this is now where we can distribute all of our information, all of our sensors in the network, and we have the coexistence to other field bus or to other protocols, to standard TCP/IP. If you have a webcam somewhere, if there is a camera required for the production, if I want to do a firmware download, I can use the same network for this. So I have, besides my real-time network, I have also the standard network, the standard TCP/IP transfer over the same network. And this gives us many other opportunities which we can use, which we can offer to the customer. And in the end, my end customer is saving money because he has just one network. And so from maintenance point of view, there is only that network that needs to be taken into account, and not several networks in parallel, and all of them influence each other. So why are we talking about an ecosystem in the end? An ecosystem we have because of we are ensuring interoperability. Let me give you one easy to understand example. Let's imagine you are developing here a drive system. You are developing drives, several drives, asynchronous, motors, whatever. In the end, Profinet is the way to exchange here in a real-time manner data. So, but on top of that, we can define profiles, we can define telegrams, we can define something like a contract between my motion controller, my PLC on the one hand, and the drive system on the other hand, which is called Profit Drive as a telegram base. And this is something from end user perspective where we have a vendor independency from drive perspective. Means we do not distinguish here between a drive from company A, company B, company C. In the end, you do not feel a difference in the configuration. You do not feel difference in your user program on the top because of the data is organized via Profit Drive always in the same manner. That means you know the velocity, you know the position, you know the torque, you know everything from the drive, and this is transferred in a standardized manner. So current value, set value, all of this information is organized here. And the interplay in the end is organized by the PLC, which is providing these technology objects. And so these technology objects give you the opportunity to run these axes, let's say in shift angular position, or that you have movements like gearing in, gearing out of axes to other axes in relation to other axes. Something like that is organized by these technology objects. And so in the end, we have the vendor independency here on the top, and we have the vendor independency also in the drive system. So how can you see this? This is, for instance, a trade fair model that we have built up. We have the several PLCs on the top, but on the other hand, 14, 15 different vendors of different drives, servo synchronous drives, and they are interacting with each other. They are driving the same model here and show the vendor independency. And in the end, from the user program on the top here in the PLC, you do not feel a difference if this drive vendor A or drive vendor B. In the end, what we are focusing today is not the topic for Profidrive. For Profidrive, we have an own workshop based on that. But what we can show you, what we can offer you today is how you can implement the Profinet into your control platform. That means into your PLC, how you can bring the technology into your devices. This is something we give you for today. So that means from device perspective, from controller perspective, what needs to be taken into account, how do you bring the Profinet technology into your devices, and what else you can do. Also, we have own workshops, own systems, how functional safety can be integrated into the devices. Also here we have, like for Profidrive, also there is a contract, let's say, how does fail-safe data is transmitted via the standard Profinet telegram. In the end, Profinet is the black channel that we are using here, and we organize some of the data then also in a fail-safe manner. And here from Profisafe state machine is ensured that there is a real communication, up and running communication between the controller and my fail-safe device, or let's say my standard Profinet device with fail-safe properties. But in addition to that, besides the real-time data exchange, more and more components are going now in today's world into virtual commissioning, into a digital twin, into a system where before you build the machine, the entire machine, you want to simulate, you want to do a virtual commissioning, and this is an opportunity that is given by Profinet as well. And Profinet supports you because of the data exchange is standardized. Also here we have again these vendor independency, and so we can simulate drives, we can simulate sensors, we can simulate the whole user program. You can even do a complete virtual commissioning of the machine. So then in the end, you do not get a surprise from mechanical point of view or from the user program. You can do everything beforehand, before the real system is built, is constructed. And so in the end, also the time to market for your entire machine or the commissioning time on site is reduced dramatically just by the foundation again, and the foundation is Profinet. So let's give you a best example what we have done. So from the point when we started the technology consulting, that means the first contact to the customer, which can be done via internet, via personal advice, by these technology workshops, doesn't matter. Then when the decision was made in the company, development time took them for 3 months. So the company was a drive vendor, Italy. He took 3 months to integrate a chip, ASIC, supporting you with Profinet, including the Profidrive profile. And afterwards, he was going to the test laboratory. Test itself took about a month with all of, oh no, this was internal test, sorry, for internal testing and so on. Took 1 month. Then he was going to the test laboratory, applying for the Profinet certification. So in the end, then the IRT stepper drive with isochronous mode. That means here also to run in these servo synchronous way was achieved here, let's say in the end, from company perspective in a 4 month development. plus the additional time spent for the test laboratory. In the end, right? How long does it take? About a week, maybe for Profinet an additional one, but it's not an endless procedure here. So also this can be done in a really short time. So this is what should be the aim, what you can do. And we will give you in the end into today's meeting, we will give you ideas on the development. What possibilities do you have? What type of services you can integrate on which hardware you can base. That means if it is just a stack perspective, or do you want to integrate an ASIC, or do you go for a complete module, ready to use module that you integrate into your devices. So, okay. Because we have many participants here that are not that familiar with Profinet, I will give you a short introduction on what Profinet is. So let's come with some rough basics. Don't want to go too much into details, but since the very first beginning, since more than 20 years now, Profinet is standard Ethernet and nothing else. So we use all of the things that everybody knows since the 70s, the 80s, when the Ethernet was developed, was invented, so that we are using standard IEEE mechanism. That means we have 100% Ethernet. We are using full duplex data transmission. We are using switched Ethernet. And 20 years ago, we started with 100 megabit per second. Now, in our days, today, we can go also to the gigabit. You can also go to lower transmission rates to 10 megabit. Also, this is possible, but this was the very basic, and this slide we have since more than 20 years in our slide set. And what is also interesting to know, you can implement Ethernet on any available Ethernet controller. There is not the requirement to have a special Ethernet controller. It can run from controller or from Profinet device perspective. That means from PLC or standard device can integrate it into any standard Ethernet controller. Of course, a certain type of memory, flash, and so on needs to be there. But from basic theory, because of we are using standard Ethernet, it can be integrated into any standard Ethernet controller. In the end, in the ISO OC reference model, everybody knows from university, Profinet itself is here, can be found more or less in the layer 1 and the layer 2. Layer 1 is a data transmission layer. That means here we have the 100 base TX for copper cables or for fiber optics is here somewhere defined. Or if it would be wireless or if it would be 5G, this is something you would find in the layer 1. So in the end, we are using more or less only the services of layer 2. That means full duplex Ethernet transmission, the priority tagging from the 802.1q. There we are done. And on top, we have here this field bus application layer. Field bus application layer means nothing else than we are having a way of configuring the devices, an offline configuration, which is, by the way, a very important one. And in the end, from automation perspective, it's not a big surprise. We have somebody beforehand, before we are starting as automation engineers, we have somebody beforehand that draws something, and this is that one that does the electrical plan, the electrical schematics, because somebody needs also to build the switch cabinet, and that's why there is somebody in front of and that does the configuration already for the schematics. And this is something now we can configure in an offline manner. This is something that the field bus application layer provides. And on top of that, also we have the possibility to download this, to do an offline online comparison. That means that the PLC is able to check if that's what I want to have, if do I really have this. We can do a comparison here, and then also to do a decision if this if it is not 100% fitting, if this difference is allowed or even not. So depending on, let's say, the firmware version, the module itself, maybe the functionality. This is something that is incorporated here already in the devices. And this is something that can be exchanged via these field bus application layers. So from device development point of view, you can decide if you will be compatible to an older version. If you release a newer version of your device, you can tell via this field bus application layer if this difference is allowed or even. Yeah, and the layers in between, more or less, sometimes used, sometimes not. It's not that important. But important for us is we are based on layer 2, and on top we are based on layer 7 with our such code field bus application. From an implementation point of view, we have different such called conformance classes, and these conformance classes in the end distinguish just on the service that we are using. Starting with the most easy one, conformance class A, standard Ethernet, no restriction on any hardware. So this can be used for wireless communication as well. Wireless in that manner that it is Wi-Fi, but it could be also anything else from transmission rate that would be possible here. In the end, the Ethernet interface is not synchronized here, and we do not stick in the end to any transmission rate. So also gigabit would be possible. And little extension we got with the conformance class B. Conformance class B means now that we are using the same services provided by conformance class A, but we added here topology information. That means somehow you need to have some information of your Ethernet interface. As long as the Ethernet interface is bounded to one port, it's easy. It starts getting a bit more complicated if you have more than one port. Why is it necessary to have this? Yeah, because in the end, we are having a network. We are having a point-to-point connection. Ethernet is always point-to-point. That means from my PC to the switch, from the switch to the router, from the router to the internet. This is a point-to-point connection always. And this is, in the end, a topology information. How do these devices are interconnected with each other? And this topology information can be used also for other things in the automation world. Something like one of my modules is defect. I exchange this via maintenance. And now, based on the topology information, I can rename, I can assign the new device, which has a location, which has a topology information. I can assign the correct device with the correct name, with the correct settings, and I can go into operation without any additional maintenance effort. So we can have a very quick reoperation of the machine again. Conformance class B. Conformance class C would mean that we are now synchronizing the Ethernet. There we need to do something on the standard Ethernet. There we are not 100% compatible with standard Ethernet. That means here special Ethernet controllers are required. This is not running on any Ethernet controller. This conformance class B can be integrated into almost all Ethernet controllers that are available on the market. Would not say 100%, but so round about 95%. Also, conformance class B is achievable. Conformance class C, then you have to have an hardware support for that. And conformance class C, which is also known as IRT transmission, this is bounded to 100 megabit only. There is no negotiation on 10 megabit is allowed or gigabit is allowed. It's not possible because here we are calculating a schedule for each and every Ethernet frame, which does not mean that inside of this, we call this an ISIL, inside of this ISIL, each and everybody has to talk this conformance class C, but around surrounding devices can be conformance class B devices or standard Ethernet components, doesn't matter. And more or less, taking this into account, what we have achieved here, we used more or less the same on conformance class B, which is also known as a TSN network. That means TSN is nothing else than an standard Ethernet as of 2020, 2021, 2022. There are minor changes in the standard itself, but this is something which you will find in upcoming standard Ethernet ASICs in the future. Maybe not as of today, but in the next 3-5 years, each and every Ethernet controller will integrate these TSN features. And we were with the Profinet standard on the very early time frame working on integrating this conformance class B or this TSN features into our Profinet standard. And interesting is here also wireless communication will be possible here. That means Wi-Fi 7, Wi-Fi 8, something like that. There will be extension for TSN as well as for 5G. Today's 5G standards are also integrating these TSN features. And communication rate is here something between 10 to 10. That means 10 megabit up to 10 gigabit with all the steps in between. So that means also 2.5, 5 gigabit also will be working here with the TSN. What devices? What are we talking about? In the end, most important things are two. One is the controller, normally the PLC, and the other one is a decentralized periphery, my remote I/O station, my network node, my I/O drop, however you will call this. The PLC is called Profinet controller. Field device, the field drop is called Profinet device. That one is handling the user program. That one is just a stupid one, which is forwarding the input information to the PLC and is reacting on that what the PLC is writing to the actor. That means switching on the motor, switching off, or something like that. It means normal standard use case is here data transfer, but because of when the device is starting up, there is also exchange the configuration. The configuration in that manner that the PLC tells the system how to work, but also the device itself tells the PLC who am I. This is exactly that what I mentioned in the field bus application layer. This is where we start here with configuration in the beginning. Then afterwards, the process data is transferred. And in case of something happens, also an alarm is fired from the devices. And there exists also the possibility for creating a supervisor. A supervisor is an engineering system under normal circumstances. They can also do diagnostics on the devices. Yeah, we can do the diagnostics to the controller, of course, but you can also do the diagnostics directly to the device. You can also read the status, the control, you can read the parameters, or you can even write the parameters. Yeah? If you're creating a drive, then you do not normally not configure the drive via the PLC and then through the network. No, we are using Ethernet, and that's why we have the opportunity to do the commissioning of the drive directly, or even remote. You can do this access to the drive if the device is connected to the internet. You can do this from anywhere over the world because we are using standard Ethernet. And so also this parameterization, this diagnostics can be done from anywhere on the world. So, and now we have here this one small sentence that Profinet is working according to the provider-consumer model. What does this mean? Let's imagine we have a controller again, device on the other hand. In between there is an Ethernet. Yeah, can be something like that. We have also the topology integrated. Yeah, that means a switch, some other devices here in a line configuration. That means each and every device has 2 ports. That's why on one port we have the connection to the left device and the other one on the right device. So now let's imagine time is flowing from top down. And now we have a cyclic communication. The cyclic communication means that the PLC is providing some output information to the device. And this it does cyclically. So why does the error is not horizontal directly? Because of the light speed has an ending speed on one hand. On the other hand, we are transmitting bit by bit, which is also time consuming, and we are delaying here in the Ethernet itself due to switches, due to anything else. And that means in the end, there is a time from start of the transmission until the transmission has finished and the information is in the device. But it's going very quickly. So we are talking about some microseconds until the information is transmitted over the network. What we do not do is, from the device perspective, we do not wait for the device as the communication is there. So we have here a provider machine in the controller, and this provides cyclically the information, and also the device is providing cyclically its input information. So we do not wait for the opposite side. We send in a predefined cycle, and this cycle can be different for each and every device. So in the end, you configure the importance of the device. You configure the configuration you configure in the hardware configuration how often, that means how fast this device should be updated. Now let's imagine something happens. Let's imagine something is in the entire network. We do not know what, so it can be a broken cable, can be a defective device, can be anything inside here. Because of the controller does not know that there's a broken device in between, and the device also does not know about something about the Ethernet has failed internally, both sides will continuously sending the information because something here inside is failing. And now let's imagine just one side of the party is disturbed. That means we do not get the information from the device to the controller anymore. This leads in the end to the following thing. The controller will recognize that something happens. The device will see everything is fine. I get my output information continuously. But then after a certain while, this is something that also we configure as a such called watchdog time. This is a setup for each and every device you can do individual. Then the opposite side, that means that side that has raised the watchdog, will fire an alarm to its partner and tells, hey, we have a problem in the communication. We need to go into a safe state and we need to reset our communication. So that means here afterwards, the communication will break and the device is going into safe state, and then the connection will be reestablished after the maintenance has done and the failure in the network has gone. This is the normal circumstance. And this is the reason why we can use standard Ethernet on the first hand, and on the second hand, can be integrated into any standard Ethernet controller. And this is the way how we achieve the real-time capability. We achieve a real-time capability just because of we are integrating this watchdog. That means it's a special type of state machine, and we are using on the Ethernet some services like the IEEE 802.1q, which is the priority information. Means we are telling the network, we are telling each and every switch in the entire network that my Profinet frame has a higher importance than, let's say, a frame from a camera, than a frame for a web server or even a mail frame. All of them would get a lower priority compared to our Profinet frames. How you can integrate this into your devices? Let's now look to the device level. That means here on that side. If you create a device, you have two opportunities how to create this. One is a such called compact field device. Compact field device means that this is more or less something like a block periphery where you have no possibilities to change something in the configuration. It means you have a fixed number of inputs and output bytes, and then this is your configuration. That means in the end, this one here, the picture behind, and all of the information here is hidden in something you need to create. This is a GSD file. This is something where you describe the functionality of your device. We build all of that information inside. So then get some input-output byte information, which is then used in the PLC for data exchange. Second possibility is to create a modular field device. Modular field device can be also something that is from hardware modular, like Lego, that you have each and every brick that you insert into your device. You can have it in the same way also here in the automation world. Or it could be also the case that is one physical device, but you would have logical extensions, something like if I want to measure that one, or if I connect that sensor, I want to have that data model, and if I connect another sensor, then I want to have another data model. So this would be also a possibility to create a modular field device. In the end, distinguishing is something that you see in the engineering system, and also something that reflects in the GSD file, in your generic station description. That means this modularity then leads into a thing that you need to configure your device, as well as you have here for the compact field device, you have just one block and you insert this into your configuration. That's it. No possibilities for the customer to change, or here in the modular field device you have other opportunities. This depends on what your device can do and also what you're willing to give to the customer or from opportunity point of view. How to implement Profinet? Because of Profinet itself is based on standard Ethernet. Standard Ethernet means a switch network. We have the possibility to run with standard Ethernet switches, or we can also integrate a two-part Ethernet ASIC into our device. What is the difference between a two-port device and a two-interface device? Let's imagine we have a Raspberry Pi. A Raspberry Pi normally has two Ethernet interfaces, but these are two independent Ethernet interfaces, and each has one port. What we are having here under normal circumstances is an automation with a line configuration, and here we are not using two interfaces. We have one Ethernet interface, but with an integrated switch in the device. That means both ports here belonging to the same logical interface, that means to the same IP address, to the same MAC address, and the handover here, if the traffic from the controller needs to be forwarded to the drive, then it's done by the switch ASIC here automatically internal. Oh, that means here internal there is a switch ASIC which is running switching between these two ports. So that switch can distinguish, is the traffic for me or needs the traffic to be bypassed to the other port. So this is something. And always you should use full duplex data transmission, because we send and we receive at the same time the frames. And if you would work just in half duplex, you will see collisions after a certain while. And that's why with half duplex, Profinet cannot survive. Full duplex is always mandatory. That means we have independent transmission and an independent receiving way in the network. So via wireless, via something else, it must be independent from each other. How to integrate this? Logical point of view now from my device. We have always one network access point, the device access point. This is where my, let's say, Profinet logic is integrated. This is the head module. This is the communication module, however you will call this. This is called the device access point. This is something you will find in your stack. This is something you will find in the development kit that they're using. And this is something you need to integrate also into your GSD file. So this device access point is always there. And then we have the possibilities to integrate the modules. and each module consists always of at least one submodule. So this is now a logical way of how to integrate this. We do not distinguish here between a modular device or a device with a fixed configuration. Also, a device with a fixed configuration could have more than one module. So no difference at this point of view. We are organized here so in logical modules which having logical submodules. Now my I/O data is assigned to these modules. And we are distinguishing now between two views on the device. One is containing the data. Data means the real input and output information. That means here drive, go left, go right, and what velocity and so on. This is something you would find here on one module. Maybe on a second submodule you would have then the Profinet interconnection, where you say I go into safe talk off, I want to have safety limited speed, whatever. This would be then a second submodule independent from the first one. Would be an opportunity. And then we could have another submodule where we have diagnostics information. And now to distinguish between the real data that is exchanged and the addressing information, that means diagnostic information. So if something happens to that module, whatever it could be, something like under voltage, short circuit, or something like that, this is something that can be also transmitted here, and therefore we have this addressing information. That means over the address information of this system, we are getting diagnostic information, while versus over the module, submodule combination, we have the data integrated. In the end, something you will afterwards see if you buy a development kit from any of these technology providers. If it is an ASIC or if it is just a spec, doesn't matter. There you will see all of that information inside. And also there you will get some examples. From Ethernet point of view, because of us having standard Ethernet, all of the information is transferred in standard Ethernet interface. To set the importance of the Profinet frames, we are having this VLAN tagging, and in the end, on the VLAN tagging, we are having the priority information. The priority is 6. So if I go one step back, all of that information here that we see here with the module 0 to whatever module is integrated, this is something you will find already here in the data field. That means in the data field, we have all of our Profinet interface integrated. It means in the end, this information here is here in my Ethernet frame integrated. Right here, my Ethernet frame integrated. It means if I have real-time information here, would be submodule 1, for instance, submodule 2 could then be I have fail-safe information, which is then integrated here. This IOCS, IOPS information is something that is filled out by the stack. Normally, you do not take this into consideration because this is something that is already provided by the devices. One thing, if you work with a development kit, in the end, the development kit gives you the opportunity to integrate Profinet in a very fast manner. Consists of a Profinet stack, always. And this Profinet stack can have different modules. Modules for having fiber optic transfer, for having redundancy, for having topology information, for diagnostics information like SNMP. CLRPC is for data for data records, TCP, synchronization, whatever. This is something normally you will never get in touch by, because this is something that is hidden in the stack that is provided by your technology provider. What you are interested in is there's an API, application interface, where you program against, and normally you get a sample application and this is something you rework for your own device. This is that one that you are adopting. So, and sometimes there exists a dependency on operating system, sometimes also the board support package, but this is something also you get from your technology provider. And normally the technology provider also takes care about the Ethernet device driver. That means that one that is then using the Ethernet interface in a standardized, in a performant manner to ensure that the Profinet interface is used in a very fast manner. So, and now it will depend on if you get this as a complete package. That means you are having an ASIC where everything is integrated on that ASIC, or if you're using just a stack and then you need to take care about the Ethernet interface by yourself. So this is what you normally get. And last but not least, also very important is always a trace interface. That means tracing for your own application, or if something is going wrong, then deeper traces are also necessary. This is how a development kit is working, and normally you are just taking care about this because your technology provider was taking care about the Profinet stack and also the integration of the Ethernet controller of its own ASIC, whatever it is, and including also the having the real-time behavior to your operating system. Good. That means normally you take care about just that interface here on the top. That's why you should normally not get in touch by the 6,000 pages of the Profinet specification, because you're using something that is pre-configured and pre-certified by your technology provider. Last but not least, do not know if everybody has heard about that. There is a such called community stack, also available in the Profinet user organization. And this gives you also the opportunity to work with a Profinet stack by itself. But the Profinet stack itself, the such called community stack, does not taking care about all of the things you get as from your technology provider if you integrate things from your technology provider. So the community stack itself is just the engine. Maybe the word stack itself is a little bit misleading. It's just the engine for Profinet. That means it is the protocol state machine for Profinet, but it does not take care about how does the real Ethernet chip from whoever you want to see is really used in a performant manner. Also, it does not take care about how does different operating systems are used. Yeah, POSIX interface is available, but how about a preemptive system here, a preemptive operating system, how to work on that. And also there is no configuration of the stack available. That means the stack itself can do controller, it can do device, but what you normally use is here on the top is the development kit API, where you program against, and where you have an example application. This does not exist for the community stack. So the community stack in the end is something that is available in the P&O if you're a member of the P&O, but the main focus is here, let's say, the technology provider, or if you're a very experienced device developer and you are more or less the technology provider for your own company. Therefore, it would be useful to work with the community stack, but it's not for somebody that wants to have, let's say, a quick and dirty device solution for his own devices. So, okay, because of time is up, I would like to hand over to Emilia? No,
no, Alex.
Next one? To Alex, okay.
Yeah. No, we have a question and answer round.
Okay.
For your presentation. And let me share again. I hope you can see my screen.
Yes, we can see the
Yes, we can.
Okay. Then we have here a first question to your first part.
Mm-hmm.
Which software where can simulate the digital twin? Do you know what it is?
Yeah, it depends on what you're going to do there. Yeah? Normally, it makes sense. Digital twin means you can have a digital twin from hardware perspective, or you can also have it from user program perspective. And then if you want to also simulate your user program and you want to do an virtual commissioning, then it makes sense to cooperate here with a PLC vendor. Means the PLC vendor normally has then a system to write PLC code and to simulate that, and also to run this on a digital twin. Or if you want to have just hardware, then there exist other opportunities. I would say from having the complete solution would be NXMCD and SIMIT together with a tier portal. That means complete possibility for having motion control application, simulation of the entire machine, including the dynamics of the machine, and doing the complete simulation, offline commissioning you can do there completely in this tool chain. Yeah.
Okay. Then the second question in this part was, what is the average time required for certification? It was you have controllers and devices and you make a development. And in this context, what is question?
Maybe I could switch in here because I'm heading a test lab, so maybe the knowledge is at my side. So I would say the average time which is required is 3 to 5 days for Profinet certification. And if you also support profiles like ProfiSafe and ProfiDrive, then additionally 3 to 5 days for these profiles. And the best practice is here to deliver at least 2 devices if one breaks, or if you want to do then tests in parallel. And but if you want to go smooth through a certification, then at the end the preparation is the most important. Use a test band bundles for in-house testing to pre-test at PITLs, and also use pre-certified solutions of the technology providers which introduce today their technologies. And also important is that PITLs usually have lead times of sometimes 4 to 8 weeks, so apply as soon as possible.
Okay. Thank you, Rai.
Yeah, you're welcome.
Reserving a time slot in the end, yeah?
Yes, of course.
Good. The next thing was your basic presentation. And the first question here was, in case of having more than 2024 bytes to transfer, is there any possible fragment to fragment image in a real-time processing? No, sorry. The first question.
There's a limitation on the standard Ethernet frame, and the definition of that has been made 20 years ago, that up to 1,440 bytes can be transferred between the controller and the dedicated devices per application relation. So one slot is allowed to be 1,024 byte long. The interesting thing is here, these 1,024 byte are consistent. So that means each sub-slot is consistent. One very important thing. Second thing is, I do not know any device where more than these 1024 bytes are necessary to be transferred in a cyclic manner. Because this would be a really huge number of of information that is transferred here, and also the PLC has to do something with that. Under normal circumstances, there are 20, 30, 40 bytes are enough for one single access for having motion control, normally 20 bytes. So if you have such large blocks, we provide also the system, or in the system we are providing other services for asynchronous data transfer. This is the data record called this service. And here data records you can organize. I do not know how many thousands data records you can organize, but per sub slot you can have, I think, 30,000 different data blocks that you transfer, and each of them can have something between 8 and 64K, depending on the controller. Also, the controller needs to understand them, and also the device stack needs to support this. 64K is the maximum size for a data record. Under normal circumstances, there 1, 2, 3K is that's what each and everybody is supporting. I think up to 8K, all of the controllers are supporting, and also the device stacks are supporting. And as mentioned, per sub slot you can have, I think, 30,000 different data records. So normally it should be enough data to transfer, and also the data records are consistent. So each data record is consistent, transferred. So, but
okay.
Maybe you have an example for me, then also we could do this in a one-to-one chat. Would be possible here to give you some additional information on that.
Then the second question is there any feature like rack optimization in CIP Ethernet tip for head devices in Profinet?
I do not know from Ethernet IP how the rack optimization is done. In the end, you're creating a GSD file. The GSD file, the generic station description, describes the possibilities of your device that it has. In the configuration, the user from the PLC, the PLC configuration tool in the engineering system, you configure now the device based on your GSD file. That means you're doing by drag and drop, or however this is done here, or the table-based manner, having the head module, and then you add the number of inputs and outputs by yourself as the device is constructed. And the optimization is done
Mirko?
I think Mirko is gone.
Optimization is done.
Mirko, please deactivate your camera, then it's your sound better.
Okay.
Your last sentence, we have not heard it.
Okay. Somehow the webcam is gone totally. I can neither activate nor deactivate. So yeah, so Profinet does an optimization of the transferred bytes automatically. So I have a lack of knowledge on the rack optimization done here by Ethernet IP, but we are not transferring, let's say, waste of information. We are transferring only that one that is configured.
Okay. Then the next question is, trace doesn't have any relation to transfer function. Data acquisition, sorry, main.
Data acquisition, yeah.
Okay, or it's just for diagnostic functions.
Neither nor for development. Trace is development. Trace is something which the user never sees. Diagnostic is something that you incorporate from, let's say, diagnostic features, diagnostic functions are already given by the diagnostic features are already given by the stack that you're buying, or from your technology provider point of view, that there is already a diagnostic feature inside. Trace is something that you require for the development phase. So that means that if you want to analyze something that is going wrong in case of a failure, if the device is going into fatal, then you need the trace functionality. Because one thing you can forget, we have cyclic data exchange. That means a breakpoint is impossible here. And so the trace functionality keeps the possibility that the device is up and running. You are working in an embedded world. So the device needs to be up and running cyclically. We have cyclic data exchange, and now the trace functionality is something that tells you where in the stack, in which line, what happened. And the trace must be organized in that manner that it can run also on an embedded device. So that's why this is a little challenge, yeah, but this is something that is solved normally by your stack provider. Only chance for development to survive. So trace functionality is nothing you will provide afterwards to your user. They will see then just the diagnostic information and no more trace. Traces are only for developers.
Okay. The next question. What is the difference between the controller communication versus the PC parameterization?
From viewed on the Ethernet, viewed from the Profinet perspective, there's no difference. It is the same service, and this is the service for data records. But if we imagine we have a drive, a servo drive, there the servo drive normally has 10,000, 20,000 parameters for the access itself. So what the access can do, what performance level it has, and so on, all of this information. And this is something which the controller is not required to do cyclic. That means you do the parameterization of the drive once in the commissioning phase, and then these parameters are stored on the drive, and the controller in the end configures only let's say the most important things to figure out if the drive is still correct and if it has the right information inside. What could be done also in case of device exchange is that we would have here a possibility to store the drive information, these parameters, these 20,000 parameters we could store on the PLC also. There exist services to do this, and to restore them in case of the device is exchanged. So there we have services in the Profinet specification defined how you could do this.
Okay, then the next question. For a controller implementation with communication stack, what configuration software can be recommended?
As mentioned, the community stack is not a ready-to-use development kit. So under this circumstance, it depends on what you want to achieve in addition. So the community stack is not a ready-to-use PLC. It is just the engine for the Profinet state machine, for the Profinet, for forming the Profinet protocols, nothing more. So if you want to have a controller, a PC, then this is a little bit more sophisticated and means here we have to have, you should look into current available controller stacks, controller software development kits that can be used. Yeah. Or you want to develop something like that, then you can use the community stack, yes, but then the PLC code on top you need to do by yourself.
Okay. Then the next question. Thanks, Emilia. Is there a recommendation for a switch chip with 2 ports to integrate into a device?
There exist various chips on the market. I think it's a good point here to ask these sponsors of today's meeting, because all of them somehow have a possibility either to do this in software or to do this in hardware already. So this depends on also in the end. I think the first choice is, what does your current device, so if you already have an existing device, what does it support already, and what in advance also you want to have. So this it means the answer depends on if you want to have IRT solution or if you want to just be RT solution, and also what does your current device already has integrated. There exist different opportunities, and also it depends on how much time you want to spend in development and how cost efficient it should be. I think more answers will come later.
Okay. Then the next question, where to define if a device is modular or compact?
GSD file. Or, first of all, before you do this decision, I think it is necessary to make yourself clear about what you are going to develop or what services are you going to present to your customer. That means in the end, this is an answer given by the functionality of your device and also how complex it should be for your user. In the end, the modular device is a bit more complicated to develop because you have more possibilities and it's more complicated or you need to spend more effort also the testing. But the main differentiation you see in the GSD file and afterwards also in the configuration on the engineering.
Can you say what the GSD file is as additional point here?
A GSD file is a generic station description. This is a way how to describe what does my Profinet device can do. So there is integrated, let's say, the vendor ID. That means who am I as a vendor, what type of device it is, and so on, and also what type of data is exchanged. So if this is, let's say, an analog module or a digital module, does it contain failsafe, does it contain profit drive? All of these things, this information is incorporated there, together with order numbers and so on.
Good. Thanks. And then we go to the other page. Is there standard Profinet support for remote devices firmware updated?
No. Simple answer: no, there isn't. Up to today, nobody in this user organization has defined a standardized firmware update mechanism.
Okay. Then, is it possible to have compact or modular devices at the same rack?
This is a distinction in the GSD file. No, it isn't. What you can have is, let's say, that you already have pre-configured modules. That means pre-configured something that is always there. that not each and every slot needs to be inserted by the user. So that means the entire module is a modular system, but you have already something which is always there, and this is something you can pre-configure. That means if the head module is used in the engineering, then these always there modules are always integrated. That means this is a combination of compact and modular at the same time.
Okay. Then I cannot see here new questions.
And we need to go on, I would say.
Yeah. Then I can say, Emilia, this is your part for the sponsoring videos.
Yes, exactly. We would like to share some videos from our sponsors that make it possible that this webinar is cost-free for you. So I will start to show the videos now. I will have to make me present it first. Oh God. 1 second, please. Yes.
Industrial automation environments are evolving rapidly to avail of the benefits offered by Industry 4.0 and the digital transformation. They're leveraging increased data to transform manufacturing, bolstering productivity, increasing flexibility and efficiency, all while reducing energy consumption and waste. Digitally connected machines, robots, field devices and control systems, all creating and sharing information, will enable Industry 4.0. ADI Cronus is a unique suite of market-leading industrial Ethernet solutions that are easily scaled and timed to perfection, turning your vision for intelligent connectivity into reality. Offering industrial Ethernet technologies, solutions, software and security capabilities, ADI Cronus is designed to connect the real world to factory networks and beyond to the cloud. Our long and rich industrial expertise and system design knowledge, coupled with advanced technologies, deliver seamless and secure connectivity across the automation network. ADI Cronus offers complete gigabit time-sensitive networking solutions for high-performance motion control in factory automation and innovative 10-based T1L solutions for robust field instruments and process control. It includes physical layer devices, embedded switches, and network interface platforms with complete protocol support. For deterministic, verified, robust, scalable, flexible, and complete solutions that simplify system design and reduce the development burden, look no further than ADI Cronus.
Die Deutschmann Automation wurde 1976 gegründet und befindet sich seit 20 Jahren hier in Bad Camberg. Mit derzeit 19 Mitarbeitern entwickeln wir hier in Bad Camberg die Produkte, produzieren sie, kümmern uns um den Vertrieb, Marketing, Support und betreuen unser weltweites Vertriebsnetz. Wir decken das ganze Thema der industriellen Kommunikation ab, angefangen von Protokollkonvertern über verschiedene Gateway-Baureihen bis hin zu Embedded-Lösungen zur Integration in die Kundenelektronik.
Hier entwickeln wir unsere Gerätefirmware Unsere Geräte brauchen auch Software-Tools, die werden auch hier entwickelt. Und natürlich entwickeln wir auch Skripte mit unserer eigenen Skriptsprache für Kundenprojekte.
Die Geräte, die hier entwickelt werden, die haben ein sehr hohes technisches Niveau. Die sind also anpassbar an alle möglichen Situationen. Natürlich ist Deutschland ein großer Absatzmarkt, aber unser Exportanteil liegt derzeit bei knapp 40%. Wir sind in Europa, in USA und auch in Teilen von Asien unterwegs.
Wir bearbeiten Kundenprojekte mit Kunden in den unterschiedlichsten Branchen.
Communication means forming relationships, sharing ideas, connecting and growing together, being inspired and making a difference. Communication is the pulse of relationships between human and human, human and machine, between machine and machine. An eternal universal principle that fascinates and drives us. We build bridges over insurmountable valleys and turn machines into intelligently networked technology for a new tomorrow. We see diversity not as a problem, but as an opportunity that pushes us forward, that takes us to the limits of the known and beyond. Communication gives expertise a voice and knowledge a form, lets us change perspective, see the world with new eyes, makes us understand, and creates change. It gets the ball rolling, which becomes a movement. It breaks down barriers and makes us fast, effective, creative. Yes, communication is what connects us. In a networked world, we expand the spectrum of what is possible and bring industrial communication to an entirely new level. Hilscher, empowering communication.
Yes, so if you want to know more about our sponsors, I already posted some links in the chat. And now I will give the presenter role back to you, Alex, I think, or Thomas.
No, it's okay. Now it's a little bit time for a break.
Yes, exactly.
And share my screen.
Thank you.
Yeah, Emilia?
Yes.
I think you was not on the end from your sentence.
No, I wanted to say thank you. You took
Okay.
the presenter role, and now you go into the break.
Good. Yeah. Now we have a little break time, and I start the countdown, and we are back in 5 minutes. Okay, welcome back. And the next referent is Thomas. Thomas, can you hear me?
Yes, sorry, I was muted still. So hopefully you can hear me now. So welcome from my side. My name is Thomas Welch from the company HMS, and I would start to give you a short overview for the easy way to Profinet. And so let's start. If you start to make a device or a controller with Profinet, so you have to think about a lot of things. What are you using? Using an FPGA, an ASIC, a stack, a module, or if there is an operating system involved, which microcontroller, and so on. And then you have to develop, to test, to certificate, to get a final Profinet solution. And now we have set up in our team here a little bit what are criteria for the selection of the technology. So this is things you should ask you before you start with the real development. So what kind of Profinet functionality performance you would like to achieve, conformance class A or C or whatever. We will have additional Ethernet functions, TCP, IP, web server, or OPC/UA, or whatever functionality you would like to add. How many space you have in your device, so what is the footprint of the hardware elements, and then for sure, how big will be the investment, the initial costs to realize the whole project to a ready-to-use product, and for sure, what are the prorated production costs for each device. Also, which quantities you would think you can achieve in the market, and also, are you supporting additional networks, other field buses, other industrial Ethernets, and so on. The same is how flexible must the solution be, and what is about the future viability, and for sure at the end, what development risks I have when I choose this or this solution to start with. So there are different solutions to implement Profinet. We will have now then afterwards further presentations about that. So we have the software solution with a protocol stack on a given microcontroller. We have hardware solutions based on ASICs or FPGAs. We have a hardware solution based on modules, and an external solution with gateways or proxies, and this will be shown in the next presentations. And also we have here a small checklist, so this can help you to find the right solution for you. So your requirements for Profinet in general or special, which time to market you would like to achieve, the target price of your device, so also the prorated production cost, the cost budget for development, production costs, and also the know-how you have in-house regarding Profinet, Ethernet communication in general, also hardware development, and for sure the resources for product support, product maintenance. And also what you would like to have is probably what happens with updates, adaptations to the current specification, how is this handled, how you can make this usable for your customers, and also is there a tested, pre-certified or reference application available? This also helps a lot during the development of your solution. So there are some more. So also, would you go for a single or multi-protocol solution? Means you would only support Profinet, or you would, beside Profinet, support other technologies with the same hardware setup, for example. So you have the offer of the technology providers here in the room. So you have consulting from the providers, you got requirement analysis, support during the entire development phase, also some architecture and design specification. So development of hard and software, it's normally your part, also creation of GSD files, but also this will be done sometimes directly by the technology providers. It depends a little bit. Also a training for getting started with the whole stuff, and for sure support for functional tests and the support of certification. So that's the first step. So I would thank you, and I will then hand over to Christian, who will start with the software solution and stack.
Okay. Hello, everybody. I will just start my presentation. Give me a minute, please. So for reasons I don't understand, here it is. So, sorry for the short delay, technical challenges. So I would like to give you a short overview why you may want to use a protocol stack, or why exactly you may not want to use a protocol stack. So I would make a brief statement about multi-protocol. I would suggest which types of protocol stacks there are available, and briefly shed light on the advantages or the disadvantages. When you use a protocol stack, you have tons of options to choose from, and of course, this is painful, but it gives you the power to make the right choice. Followed, I will provide a brief conclusion, and the last statement will be examples for minimum configuration. So, protocol stacks, why? There are definitely very many reasons to employ protocol stack. For instance, one of the reasons is you can seamlessly integrate your application and a protocol library in the same project. You can employ one core on a single core CPU. If you have a multi-core CPU or hybrid core CPU, you can employ multiple cores. You can make load balancing. You have a lot of options, and so the choice is again, it's yours, and especially when you have a protocol stack, you can reduce latencies and jitter to a minimum. This is important, since if you handle messages from one core to another, you will technically based have latencies, you will have probably jitter. This can be perfectly acceptable, but in a protocol stack executed on the same core with the application, with your application, this is reduced to an absolute minimum. So, for instance, we were looking at interfaces. If you are having enablers or external parts, you have an easier to handle interface. This is for sure. This may lead at a certain point in time to limitations, since the interface can carry or handle only a certain amount of data in a certain structure. Again, perfectly acceptable. These limitations may be good for you, maybe not good for you, your choice. For sure, you can make bill of material optimization. You're having only one microcontroller, one set of RAM, flash, and external parts,
and you can handle all within the same project. So this is simply perfect. However, it also challenges you the most, and this is important to understand. It is your application competes with the protocol library, and both of them are probably very demanding and very important applications within your device. So the BOM optimization comes at a price. So of course, you have everything in one microcontroller. You can really create the best performance. There's no question. You have the options to challenge the Profinet functionalities to the maximum. So you're not limited to any buses or anything like this. But again, it comes at a price. So the protocol stack is really your option to meet our recent and most important, maybe coming future requirements. Since you know, if you create a device and you introduce it to the market, there are coming wishes from the customer and requirements from your sales team. So the protocol stack leaves you the most options, let's say that way. So again, why not employing protocol stacks? And this is really important to consider. You will have so-called fun in understanding the protocol stack, understanding how it's programmed, whether you have it in source code or in binary form, it doesn't matter. You still need to understand and face the requirements the protocol sets to your application. And this is something that takes time. Of course, employing a protocol stack is probably time consuming. You may go not for protocol stack if you're not having this development time. And if you're not willing and able to balance everything within your microcontroller or within your multiple cores. Maybe you don't even want to understand this protocol in so many details, since you simply want to focus on your functionality of your device, and the communication is just a means of getting the data out of your device. You're not having a lot of time to get involved with the communication, troubleshooting things you wouldn't need to troubleshoot with an external part. So, and you should not go for a protocol stack if you're having just minor functionality, low quantities, and you're not interested in offering to the customer tweaks or special functionalities. You should consider, is the interface bandwidth of an external enabler enough for you? Is the interface structure good for you? Go for an external enabler. If you are having large quantities, if you are having time, and if you're having special requirements from your customer, consider the protocol stack. So one other story to consider is the multi-protocol. So we are certainly having only few devices which are needed to face one single protocol only. So we see many customers needing to support several protocols in their devices. And so you may want to consider the choice of a protocol stack also with the requirements of other protocols. Is from the vendor of your protocol stack other protocol implementations available? If there are options, can I handle this in another way? So again, all your choice, but also all your option. You may want to consider your choice of silicon at this point, also from the focus whether there are infrastructure functionalities available in silicon or respectively on chip. So this may influence your choice, and your choice of silicon may influence your choice to go for a stack or not to go for a stack. So again, options and options and options. A big story is whether your manufacturing needs the flexibility to decide the protocol later. This is, for instance, also a factor that influences your decision, or may influence your decision, since it allows you further BOM optimization. You simply manufacture one device, and once you put it in stock, you decide whether it's protocol A, protocol B, or whatever. So this leaves you the choice to make a better optimization. Of course, this comes again with the drawback of more development effort. So one important point also to look at is your development project, whether it is okay to handle server island project, since you have a solution for protocol A and a complete different solution for protocol B and yet another option for protocol C. You may accept this or you may want to say, I want to have one continuous development project and create all of my protocol derivatives out of one project. Again, choices over choices and options over options, but you have them. Well, protocol stack, there are different types, at least from what I personally see. We see protocol stack solutions that are coming with a certain silicon. And if you have a silicon which comes with a choice of, which comes with protocol stack included, then your choice is already done, not by yourself, but by the silicon. So if the silicon comes with a stack, go for exactly the solution. So then we see bare stacks, which are only including the functionality of the protocol, for instance, the bare Profinet protocol library. And these are good to enable in the host system, into your system. However, it also requires the most effort at your side, since you need to add Ethernet functionality. You need to add flash handling, RAM handling. So there is just one building block, this bare stack, and it leaves you all options, but you need to also handle these options. So this increases your development time even more. Then we see device kits, which represent the stack, plus a lot of accessories, and basically these device kits represent a complete device with all accessories, and you simply can extend this device. These device kits also come with the platform support for certain silicon vendors, and once you have this choice made, you have a complete device for your silicon, and you can start rather quick. Still, you're handling or dealing with the protocol stack. Such kits usually come with also switch management, and I will talk later about the Ethernet switch. This may be included and save you a lot of time and a lot of trouble. So you can go for complete stacks, like for instance, Mirko pointed out the community stack. It comes with absolutely everything. This is, you need something exotic, go for it. It's included, it's there, you have it out of the box. Usually, if you have everything supported, it costs resources. And if everything is there, it may happen that you may need to address large portions of this. So it's important to understand, if you go for a complete stack, it's certainly not the most slim solution and probably not the fastest solution. However, it's the most powerful solution, no doubt on that. Then there are lean stacks, which provide a typical subset of features. So what, let's say, most of the customers are okay with. These are usually very slim and relatively fast and easy to use. There may be one or the other feature be missing, and this is something you may deal with it with. It saves you time, it saves you space, resources in means of RAM, CPU, power, and flash. However, you can even implement such stacks in Cortex-M MCUs. And it's not about Cortex-M itself, just about these class of devices. I try to make to draw a conclusion here. You design from scratch, you have a complete new project, and you don't care about the silicon. Consider plenty of resources for Profinet, and you will be safe. And the sales force who introduces your device to the market will fill these unused resources. Be sure they will find features they definitely need to sell this device, and you will be happy to have some spares left which you can fill later. So if you design from scratch, and you make a brand new start, consider very well which protocol stack you're using. However, then your protocol stack choice may be the right one. If you want to retrofit Profinet, so you have an existing device, an existing design, and you want to support other Profinet and maybe other protocols, you need to carefully consider whether your silicon has enough resources left. And this is not only RAM and flash, it's also CPU performance. If you have a multi-core CPU, a mighty powerful multi-core CPU, you may want to consider balancing the load over cores, having the operating system balancing, or you may even go for not balancing this by dedicating certain cores for certain activities. However, if you make a retrofit of a protocol stack into an existing design, be aware Profinet stack, also lean Profinet stack, is demanding, and if you have already very carefully constructed and fragile interrupt scheduling, be sure Profinet, not Profinet, any protocol stack will wreck this interrupt scheduling. So if you retrofit into existing designs, be very carefully and make an extensive consideration phase how you accomplish this. So last but not least, implementing protocol stacks needs really carefully planned. But once you make a good approach and you do this carefully, you are safe, and you can optimize your BOM cost and your design. So just examples, this is for conformance class A, conformance class B, based on a lean stack. You can handle Profinet in already 200 kilobyte RAM. Of course, this is absolute minimum. This is just bare Profinet. Profinet works as it is supposed to be. It's not your application being included, it's simply Profinet. We said you may want to consider at least 256K byte RAM for a real world device, and you should consider probably 1 megabyte flash, again only for Profinet. If you go with a lean stack, already a Cortex-M microcontroller will do the job, roughly clocked at 100 megahertz. You can even accomplish 1 millisecond Profinet cycle times. This is definitely possible, and you can even go and use a microcontroller with a single Ethernet port on switch, and you can add an external layer 2+ switch controller. So one of the previous questions was an example. So one example I could give here is a microchip part. This is the former Candin KSZ Kilo Sierra Zulu 8863. This is a small 3-port microcontroller. It's a managed microcontroller, and this is an important remark I have to give here. If you add an external switch controller, you need to be aware it is a managed switch you're adding there. It's not a plug-and-play switch. It is a managed switch. You need to hook it up from your on-chip or from your microcontroller's MAC to the reverse MAC of the switch controller, and then you go with 2 external ports outside, and you need to add an SPI for management, and your device kit needs to come with the switch management. Otherwise, you will reinvent a small managed Ethernet switch. So, important conclusion, a small Ethernet switch connected in front of a Profinet device makes the Profinet device a device with 2 Ethernet ports, and you need to manage this switch completely. So another option would be a lean protocol stack employed on Linux platforms, and here it's already possible to use a Raspberry microcontroller, and you can accomplish with the standard on-chip Ethernet interface 60 millisecond cycle time. If you tweak it a little bit and carefully build it in, you can even accomplish 8 milliseconds. So I would conclude here and say thank you.
Then I say thank you, Christian. And the next one is Nico. Nico, you are muted.
Yes, sorry. So good morning. So, okay. So, yes. So then, good morning and good afternoon also from my side, and welcome to the technology workshop. In this session, I'm going to emphasize on the available chip technologies in the market that together with the protocol stack enable to connect machines, equipment, and devices to a Profinet network. The underlying question is, what are the market differences in terms of value proposition? And the underlying question is, what are the market differences in terms of value proposition for the different chip technologies, which typically vary based on factors such as type of technology, performance, efficiency, integration density, and their suitability for application use cases. So understanding these differences often helps embedded designers to tailor their products to application needs. On a high level, Profinet device integration into embedded systems relies on the interplay between hardware and software that determines the feature set for the Profinet conformance classes. As you heard in the previous session, Profinet defines different conformance classes. So it starts with conformance class A, based on standard Ethernet with real-time communication and cycle times, typically 10 milliseconds, even down to 1 millisecond is possible. Then we have conformance class B that adds on top specific features such as network protocol management and so on. And we have conformance class C with distributed clock synchronization for cycle times below 1 millisecond, applicable for motion applications. Just as a side note, I'm not going to talk about conformance class D yet for gigabit TSN. The reason is that products cannot be commercialized yet. Some manufacturers announced TSN support as well as produced first chips, first test chips. But a chip alone doesn't make a final product, so it requires specific software, configuration tools, interoperability testing, as well as conformance testing. So we will see solutions, commercial solutions, also for conformance class D, probably within the next upcoming 3 years. So what does the market offer in terms of chip technologies for Profinet? So there are general purpose microcontrollers and microprocessors available with a standard Ethernet MAC suitable for conformance class A. Then there are so-called system on chip solutions, SoC, that focus more on the system level and combine the advantages of microcontrollers and microprocessors. So you will find two groups of devices. One group is a kind of feature-defined real-time switch IP for conformance class A and B. And you will also find a group of devices that have more kind of software flexible switch IP that also supports different real-time Ethernet dialects. This switch IP has a RT and IRT capabilities suitable for conformance class A, B, and C. Then we have FPGAs or SoC FPGAs. On SoC FPGA, on top has a kind of standard processor core, standard on-chip peripherals, in addition to field programmable gate array. For the FPGA, there's typically available configurable switch IP core suitable for conformance class A, B, and C. And we have ASICs, so application-specific integrated circuits, sometimes also called ASSP for standard products. These are purposely built for Profinet, support a full feature set, suitable for conformance class A, B, and C. So what does the market offer in terms of software solutions for Profinet? There are full service providers that provide tailor-made solutions coming in different form factors. So they provide the chip technology together with the protocol stack, and they provide maintenance and support services for the protocol stack. Then there are software service providers for the protocol stack. So they offer protocol stacks for various chip vendors. So you get a stack from the software vendor and the chip from the chip vendor. And also these companies provide support and maintenance services for the protocol stack they offer. And as you heard previously, we have a community protocol stack. It's primarily a kind of bare metal program state machine adaptable to chip technologies, but it requires a profound understanding of the standard and the Profinet technology in order to use it. And there are product certification services available, offered by a global network of independent accredited PI test labs. So a Profinet device integration into an embedded system can be based on a two-chip solution. So for the companionship use case, the market offers system-on-chip and ASIC solutions. These solutions have an integrated Ethernet PHY, they have an on-chip CPU for the protocol stack, and they provide an external host interface for the cyclic I/O data exchange through the network. The advantage of this solution is there's a kind of generic Profinet network interface, and the host CPU is scalable. So depending on the target application, it can be a microcontroller or a more high-end microprocessor unit. Also, this solution enables to use a low pin count host interface. It can be as simple as a serial interface to exchange the cyclic I/O data. On the other spectrum, there are FPGA solutions available with a switch IP configuration for Profinet for the switch IP. These devices typically require external Ethernet PHYs and have no on-chip CPU for the protocol stack, which means the protocol stack is also on the host CPU side. You need to take into account that you need a higher performance host CPU for the protocol stack and the application layer. And also depending on the solution, most likely you need a higher performance host interface for the register and switch memory mapping to the switch IP core. To give an example, typical example for a two-chip solution is an example for industrial panel PC with network connectivity. So there's a main board. On the main board is a high-end processor, multi-core processor with a graphics engine for the panel display, and the Profinet connectivity is integrated based on a mini PCIe card that is plugged into the PCIe port. And you can see here, this is the interposer for the connection to the physical connector. And then it's also possible to have a Profinet device integration as a single chip solution, single chip use case. So the market offers single chip solutions with a shared CPU for the protocol stack and the application, as well as with a separate second CPU system for the application. So it has a tighter integration, enables a low latency synchronization between the protocol stack and the application tasks. What it means, it reduces the CPU load for the synchronization tasks. There's a more tighter integration, and it's also suitable for more performance-constrained devices. So the market offers ASICs and system on chips for the single chip use case with integrated Ethernet PHYs, so it runs the stack as well as the application. Their suitability varies by the application feature set, depending what you need for your application in terms of CPU performance, as well as peripheral feature set. But this solution also enables the smallest possible hardware footprint. On the other spectrum, there are more SoC FPGAs or SoCs, which provide more performance capabilities for target applications. These solutions typically require an external Ethernet PHYs. Suitability depends on the application side, and they typically have a higher performance application CPU for application tasks. To give an example for a single chip use case, this is a single axis servo motor drive that combines the network communication and the motor control features. It is suitable for space-constrained application and harsh industrial environments to equip electric motors and encoder with a Profinet network interface. And this enables to integrate the PCP directly into the housing of the motor. So you can here see this is a system-on-chip solution with network connectivity and motor control, and the power stages to drive the motor here externally. And this is a system-on-chip solution, an example for it, how the block diagram looks like, and it can be used either as a companion chip or as a single chip, depending on the use case. The architecture is composed of a communication subsystem with a CPU, with a switch IP, integrated Ethernet PHYs, embedded flash, and RAM for the Profinet protocol stack. It is a block of shared functions that serves both segments of the chip, and in addition, a second CPU system for application tasks with another CPU, embedded flash, RAM, as well as standard and industry-specific peripheral units for application developments. For the communication subsystem, the Profinet firmware is available as a pre-certified protocol stack. The solution offers different network interface options, has an integrated tool 10BTX Ethernet PHY, or can be used as external PHYs, for instance, 10-base T1L Ethernet PHY via MMI. The external host interface for the companion chip use case can be either a single or quad SPI, or an 8 or 16-bit parallel interface. And for the host CPU, there's a toolkit available in API to access the toolboard memory through the host interface in order to exchange the cyclic I/O data with the network. The system memory is also extendable, for instance, for web server applications or IoT connectivity, so it has a dedicated quad SPI with execute in place for external serial flash and a shared 16-bit memory interface for external SRAM. This example has a single 3.3 volt power supply system and comes with built-in diagnostic and security features such as hardware root of trust for secure boot, as well as cryptography accelerators for transport layer security protocols. On the application side, the second CPU system for the application host is an internal host interface with single cycle CPU access to root port memory, provides a range of serial interfaces, standard as well as industry-specific peripherals such as I/O link. It enables single access control for motor and encoders and so on. And host software examples are available for the on-chip peripheral drivers. There's a field-oriented control software for servo motors, as well as Profinet application software examples. This solution is available in different form factors. It starts off as a system on module with different external memory assembly options, depending on the use case, as a mini PCIe card, as well as a system on chip, along with development kits and a Profinet firmware for product development purposes. So this is my final summary to give you a range, an overview about the available chip technologies and some indications about the solutions that are available in the market.
Okay, then I say thank you, Nico. And we have the next Q&A session. We have currently only one question, and this is a question for Christian. Can you please put the chip part number of the switch into the chat?
I will do this.
Okay. Only one question, what we have currently here.
So then I would say we would just go right straight to the rest of the sponsor videos.
Yeah.
We still have 3 left. So I will take over the screen then. Yes. So
What does connection mean to you? In an increasingly complex world of intelligent devices, we can make your industrial network connectivity simple. At HMS, we believe that connecting matters in everything from making machines talk to engaging with our customers. Our state-of-the-art technology provides a fast and easy way to network millions of industrial devices all over the world. And as technology evolves, so do we. Millions of devices rely on HMS connectivity. From factory automation to connected buildings, remote solutions, and future technologies, we provide innovative solutions that save you time and money, creating a more productive and sustainable world. HMS stands for Hardware Meets Software. With our unique solutions, we enable seamless connectivity over the edge between industrial equipment and IoT software. As your industrial Internet of Things innovator and expert, we take the complex and make it simple. From the device to the cloud to you, we make connectivity easy and secure and turn your data into value. No matter where you are, our team is always close by, supplying what you need to solve the problems of today while preparing for the challenges of tomorrow. Because when your devices are fully connected, you can focus on what you do best, your business. But don't just take our word for it. See for yourself. Welcome to HMS, because connecting matters.
Why actually Profinet? Profinet is one of the leading Ethernet-based field bus systems. Due to the high Profinet market share, you benefit from exponentially increasing node numbers every year. The openness of Profinet and a strong community make it easy to get started. What technical advantages does Profinet have to offer? Profinet offers highest performance, maximum safety thanks to the leading safety protocol, sophisticated security concepts, and highest quality assured by certification. In a nutshell, Profinet is the solution for your application. What does Siemens offer for integration of Profinet into my product? We offer solutions for all areas of application, for Profinet controllers and devices with RT or IRT. The Profinet driver is a software package optimized for Linux operating systems to develop a controller or a device. For Profinet RT, even independent of the used Ethernet hardware. The Enhanced Real-Time Ethernet Controller, ERTAC for short, from Siemens is ideally suited for developing Profinet field devices for drive technology, factory automation, and the process industry. Our development packages make it possible to realize complex requirements in the shortest possible time. We support the Profi Energy Profile, also offer application examples for the Profi Drive Profile, and enable safety applications with the Profi Safe Starter Kit. We are happy to support you in integrating Profinet with our development products as well as in certification. Our Profinet solutions are the result of decades of SIMATIC experience. Because Profinet is the communication system for SIMATIC, today and in the future. We make this know-how available to you.
Welcome to TMGTE from Karlsruhe, Germany. We are a technology and service provider in industrial communication. In addition to embedded software, we also support our customers with device engineering tools. As a competence center, we help you from getting started with the technology through implementation to certification. For Profinet, we offer our Profinet I/O device stack. It's according to latest specification, is highly portable and supports conformance class B or C. It can be used with single-chip microcontrollers due to the low memory footprint. It supports, among other things, fast start UP, media and system redundancy, as well as the multi-instances for PA Profile 4.0. It can be used with Profi-Safe, Profi-Energy or IO-Link integration as well. We are proud to have supported the first implementations with the Advanced Physical Layer APL. Here are some platforms supported with our stack. We are also specialists for the implementation of IO-Link masters. Our IO-Link device tool version 5.1 is open to all IO-Link devices, supports the masters from many manufacturers, and can be integrated into the TIA portal via TCI. We look forward to get in touch with you.
So, that were the videos, and you will take yourself the presenter role, Alex? Thanks.
Yeah. I have shared my screen and I start the counter for a little break time. And information to the next reference. We have not many time. Please look to the time in your next presentation that we have enough time for the Q&A session on the end. Okay, then welcome back. And Thomas, you are the next one.
So, hello again. going to the third part of implementation possibilities, now with modules. So the main steps in designing a communication interface is hardware. Find, select the hardware components, then software. Develop and or buy stacks, adapt to your needs. Test, manage testing and fulfill certifications from the organization. And then for sure production, and then you have the product launch. And then you have the maintenance phase through the entire lifetime of your product. So provide technical support when customers have network issues, also manage updates of the network and what you're doing with hardware redesigns and so on. So this is the process you normally have. And you have already seen the software stacks and the chip solutions, and now we are going for the module-based solution. So there are some advantages, also some disadvantages for sure. Each solution has advantages and disadvantages. So you have an all-in-one module, including connectors. You have a slide-in slot. You also can get this or can make this available to your end customers as an option. So the user can install it afterwards if he starts without communication and would like to add the communication later on. So you have this after-sales option. For sure, it's a solution with a 2 CPU solution. So there will be running the protocol, everything on the module, and you will have a host CPU with an application interface and hardware and software to connect the module to your. And also there are available some picky pack modules, which is a reduced set. Normally, you have the free connector choice. That means you can achieve instead of having 45 tracks, you can have M12 to get a high approval for your for the IP of the whole device you would like to have, and it's a little bit more compact and a little more economical than the module, and it looks like this then if you put it on a PCB. So the ready-to-use communication coprocessor, you have a low code for time-critical mechanisms. The synchronized communication is implemented, network redundancy, and also performance, things like net load to prevent your device from hanging up in the network. So you have high-level protocol adaptions. That means you don't have to know each part of the Profinet stack. So you know how the parameterization is, diagnostic features. You have the API for your host, and you have additional management interfaces, typically like web, FTP, or something else. Also, there are already modules which comes with other options like OPC-UA and other features on the market. And so typically general hardware application interfaces are parallel in 8 or 16-bit SPI. Also serial UART are for all the devices available. You have a flow control and reset, so you can reset these modules, and you have an interrupt way to signalize that data is there. And often the modules come with a detection, so it depends. So you can make one application independent of your network with one design, one software design, and through the detection you easily can start up then the system. Say, okay, I'm now running with Profinet or running with Profibus, for example, or a complete different network. So this is still the advantages what you have with the module compared to the other solutions where you may have to make more effort to achieve the same functionality. So the Profinet protocol-specific mechanism completely packed in the module. You have only one hardware interface independent of the protocol, and typically they are applicable for all the existing conformance class, with a small remark on conformance class D. As you heard before, there is still missing conformance tests and some other things. So as soon as this will be available, there will be also modules available for conformance class D and TSN networks. And what is very important, the maintenance of the technology is covered by the technology provider for the module. So is there any updates in the Profinet stack? Are there any other things coming up? This is typically done by the technology provider, and it's independent of your application, and you have not to adapt a new Profinet stack or whatever in your application. It has to make there a big rework. And for sure, there is a conformance certification for such solutions always available, so they are pre-certified, and you can easily start. So also the application software interface is typically independent from the protocol specification. So you have a host CPU, you have a communication module, a software interface, and you easily can have, if you have there a master on the other side, you have the description file, the GSD file, and then you have the just exchange the data what you would like to transfer to the PLC in both directions. And typically all the providers offers starter kits with modules and also providing examples for the host software interface for a quick and easy implementation, as well as the GSDML file are already as example available, but you just have to extend to your own needs. So you see here a starter kit, for example, and typically you also got to support during the complete development process until the final certification. And for sure, you have a startup in a few days, so very easy to start with the system and to get a full system running with your demands. And here is an example how the mapping could be. So you have their ADI. So we just have the way how you define the data, and then it's completely independent how it is mapped to the different networks. This will be done then in the module. So you just define your communication between the module and your device, and then the rest is done in the module. So if you have one network running, it's a low implementation to add different networks, and field buses can easily exchange to different networks and field buses by just removing and plug in another module. There are also options available, as mentioned before, like OPC, MQTT, and so on. And for sure, future-proof to next technology solutions. TSN security, what comes up? There might be different new networks we don't know today. So it can be easily then adapted without changing your base hardware. For sure, it's perhaps the fastest way to integrate Profinet into a device with low development risks and efforts, because you just have to add the connector for the module. You have no protocol expertise is required. Multi-protocol is available, and you reduce maintenance effort and you can have a quick evolution to new technologies. For sure, there are also the negative aspects. You have a complete additional hardware in a module pack. This means there are additional chips on it. So you have a complete additional plug-in device. This means you have a higher price compared to an ASIC or a protocol stack. So this will not fit to a solution where you have really high numbers of devices. Then you might have the development costs will cover the more cost for the module, but for a lot of solutions, it's still a good way to do this. So then I will start directly with the next implementations. So this is all the presentations you have seen before. Even with a software chip or module, is to integrate something in your device. But there is a different way how to connect devices to a Profinet network, and we are talking here about gateways. Typically, this is used for retrofit, or if you have a device with an interface like serial, which is typical, and you would like to add this to a Profinet, but you have no high numbers, it isn't worth to integrate Profinet directly in this device because you have only a single number of devices a year you sell to your customers. Then often the protocol converter is suitable for that. So you have Profinet on one side and serial on the other side, and you just configure how you exchange the data on the serial way and put the information into Profinet in both ways. And then another gateway or called proxy is to have Profinet on one hand, and you have multiple devices connected to these gateways as a field bus or whatever. So, for example, a CAN open network below of this or a different field bus. So this is also a way to get connected to Profinet, and for sure, all gateways or protocol converters need a little bit more time. So this is probably not suitable for all applications, even if there are high demanding cycle times are needed. So this is how it can look like. You have your equipment serial, just connect this to the device. On the other hand, you have Profinet and or any other protocol you have there, and you can use it. So it's the easier and fastest way to connect a controller-based equipment to Profinet without electronic or software redesign of the device, without certification and development risk. And it's only configuration. There is no programming of the converter. It's just parameterization configuration. So this is for sure the easiest way, but for sure this is a complete external device. This makes it more or less even more expensive than the solutions before, and is often used in retrofit applications, as I mentioned before. And you're just mapping the protocol, so often used as Modbus. It's easy to register. Often also proprietary serial protocols, and then there you have to have a little bit more attention required to support the serial functionalities. But there are templates available to simplify user setup of the serial side. And here is a different one in case of a proxy. So you have here, for example, a sub-network with CAN, so you have the different CAN devices, and you just also configure the devices and have then the information exchange with the Profinet. And what also is becoming more and more popular is gateways, or we call it today more coupler. This is coupler between the same network or different network. So you have two machines with different PLCs with different networks, and you easily can exchange from one network to another network, or you can separate. If you're having Profinet on both sides, you can separate the machines and just define by configuration of the gateway which data between the two machines should be exchanged and whatnot. This is also becoming, in case of security, more popular to have these couplers to separate the networks. So, and this is also a very easy way to connect PLC-based equipment to Profinet, so you have no change additional interface of the internal equipment PLC. Easy to integrate the gateways in PLC programs. It's only configuration and no programming of the gateway again. And as I mentioned before, consider always you have a delay in communication cycle time according to the applications. So if you have a gateway, you have protocol cycle time of both sides plus gateway internal transfer. This is normally very fast, but there is no synchronized communication possible because you have two different networks with their own cycle running. But you have the solution with a low data transfer time available. So generic considerations: easiest and fastest way to connect with unchanged equipment, internal control, no hardware software engineering project, resources required, no implementation risk, and certification, as gateways are already certified, available from the market. It's only just configuration. Typically for low numbers of devices or retrofit used in the market. So you also can talk to the providers for some additional things like branding or evaluate. You also can use evaluation, additional external protocols and communication required to your already existing device. So you can just check, will fit Profinet to my device as I expected. Can be used for retrofit, as I already mentioned, and for sure most of the providers offers branding of product configuration and diagnostic and so on. So this was the implementation with the modules. I hope we were able, all of us, to give you an overview over the different possibilities how to build up your device, and for sure it's your choice which one fits best to you. And then I would hand over to Raik.
Yes, it's. I hope you can see my screen and hear me as well. It's now more challenging for me because we are around 20 minutes behind our scheduling, but nevertheless, welcome from my side to this webinar. I want to present the topic Profinet certification, why and how you should certify your device. Today's talk has been shortened from around 30 minutes to 10 minutes, so by far not all slides which have been provided are shown by me, but for questions I'm available in the chat or maybe after this meeting. Okay, let's go to to the next slide. Here you can see the items I want to address in the next minutes. Motivation means why, overview of the processes, the test environment and the tools, some specialities regarding controller and profile certification. Then I will introduce the different test bundles which are available and give you a short outlook. Then how you can come from the test report to your certificate, and finally some links and contacts. So what do we want to achieve? We want to achieve conformance, interoperability, and also availability, which is ensured by the net load test. To meet these quality requirements, Profinet certification has been made mandatory. At Profibus, it was only a strong recommendation. Here you can see a body shop with 150 welding stations, 800 robots, 10,000 Profinet devices from more than 20 vendors. And this, at the end, can only be achieved through this quality, which is ensured by certifications. Let's have a look on the process sequence. On the left-hand side, we have a comprehensive Profinet specification. Out of this is specified what is tested in the so-called test specification. We define meaningful test cases which are largely automated, and there is defined how it is tested. We have a test environment which is specified and thus uniform across all the laboratories worldwide. And at the end, you will get your certificate. All the necessary tools are part of the test bundle. So regarding the standardized test environment, we have a defined Profinet tester, defined PC. We have a controller, we have switches, neighborhood devices, switchable power strip, and so on. And everything is defined in the test specification. The test cases itself are largely on this ETS, which you can see here in this picture. The test bundle itself is available free for charge for all PI members, and it is annually released. It can and should already be used during the development, because this preliminary testing can be used to get more effectively through the certification in the test lab. But test labs, of course, also offer pre-testing. The bundle itself includes various tools, and by importing the GSDML file, the test system acquires the necessary knowledge about the device under test. So inside the test bundle, we have different tools, as I said, the automated runtime tester for testing startup state machine and so on. And for the conformance class C devices, also the tools called BERTA to checking synchronization stuff. Inside is also the GSDML checker for syntax checking. Then we have a netload test based on Ubuntu for 100 megabit. For APLN devices, we have a netload test which is already included in the automated runtime tester. And finally, also an interop test with various controllers and devices, and to check here also the startup behavior. Let's have a brief look on the controller certification. For controllers, there does not exist any GSDML, but to get the supported features of a controller, we created a similar XML-based controller description. This has to be provided by the manufacturer. We have interop tests, which are done to check the AR establishment with different devices using different GSDML versions. And of course, also application is needed for the controller. So you have to engineer something. And the requirements for these are described in the so-called test flow protocol chart, which is inside the test bundle. And also we added 3 example applications from 3 different vendors. And the art at the end simulates the devices for the controller. So profile certifications we have as well. All have in common that they require, as a prerequisite, a Profinet certification. For ProfiDrive and encoder, we have a profile tester bundle to test the different application and encoder classes. We have for ProfiSafe a layer tester for checking the transport layer, and but also some F-parameter assignments tests which are integrated in the automated runtime tester. And for several years now, we have also the Profi Energy test cases inside the automated runtime tester to check saving mode, service, alarm handling, wake on LAN, and stuff like this. Okay, now let's have a look on the different test bundles which are available for you. This certification test bundle is used for official certification and should be used, as I said, to prepare for the test. It offers long time stability for device vendors, and yes, it can be downloaded there. So in addition to this certification bundle, we also offer some trial bundles, and they are released on a quarterly basis. They provide the latest state of implementation in a separate bundle, so you can give feedback. You can already have a look in what the tests are developing to, and can also check your implementation against the latest state of this test tool. And what we used also in the last year for the first time are innovation test bundles. We used it for APL end devices and also for the PA Profile 4 certification. It is used to have a fast release of new technologies, and it is on the one hand also only for a small number of devices relevant. And it is only released on demand, but we want to have these new technologies in time, and we don't want to wait for a next certification bundle. And so we also introduce this kind of bundle. And the best at the end is all these innovation bundles will be then integrated in the next long time table certification bundle, as it was done for the 2.44.1 in last year's summer. So what is our vision in the word cloud? From Mentimeter, I have seen also the buzzword ETS. ETS means embedded test system, and this is our new way how we want to migrate all the test applications in a long-term way to this platform. And we already achieved there some steps towards this vision. It means that we released first test cases. At the end, we also integrated all device test cases with the last year release. We plan now to integrate all the controller test cases till summer this year. Means that we then can completely also test all the controller stuff with ETS. And we also have the goal to achieve security class 1 for device and controller certification also within this year. And then a lot of other things. We want to have the net load testing also for 100 Mbit and 1 gigabit on ETS and so on. So be curious at the end. We want to push this. Okay, then a short look on the procedure, how you come to your certificate. Everything is described in the quality document, how to get a certificate. You apply for a certification test at a PITL. Please in advance with some weeks. As I said before, it may have lead times from 4 to 8 weeks. And then the test laboratory performs the test and establishes also the test report. And with this test report, you can apply for a certificate at the PI central office, and your certificate will be issued using the data in the test report. And then you have the choice to integrate it also in the PI product catalog. The test system itself, it's very important from my point of view. It has a validity period in sum of 16 months, where you can apply for a certification. And then you have a phase-out time of 6 months, and within this time, the test must be completed. Otherwise, the next test bundle needs to be used, which means at the end more test coverage, additional test cases, and maybe some new errors you will face then. And during this overlapping phase, you will be asked if you want to go with version A or A+1. And yeah, here please keep in mind that it will fit to your roadmap, and you don't have to do double efforts using then 2 versions, which you have to test against. Okay, and this is more or less some summary of important information and contacts for you to go after this meeting. You can click through, and yes, last but not least, here you can see the product finder. It's a good thing that your customers can easily find products and also the certificates which are bounded to these products. Then I hope it was not too fast, but I was a little bit in struggle now. And I wish you good luck with your product, and thank you for your attention.
And I say thank you, Raik. And share my screen again for the questions.
Maybe let's start with the questions for Raik. I think Thomas can.
Yeah, let me move my pointer to the other page. Raik, you have the first question here.
Yes, which is about Profinet if your test cases failed and passed with a standard. Okay, it's some specific questions. In general, the first one, ETPS only for testing. No, it's a general. The ETS port is now used for each technology, not only for Profinet over TSN, but for Profinet over TSN, it is mandatory to have this ETS board because of the 1 gigabit support of this board. But as I said, it is used for everything, also 100 megabit based, 10 megabit based. It is used for, at the end, for all the certification of Profinet devices and controller of all conformance classes. And the second part, if your cases failed with ET and passed with the standard, but this is really too specific or not specific enough to be answered. It can be because of porting of test cases from standard to ETS, that maybe the timely behavior has been changed, or maybe some test coverage was added, but it cannot be answered in general. And the last one, what about cybersecurity certifications? Is network load the only test included today? So the net load robustness test is, as far or right now, one thing which is inside the certification since some years now to be more robustness against load scenarios, but in addition, we plan to have now then a security class 1 in place within this year, but there's some basic robustness in addition then regarding DCP and SNMP, and also the GSD-X signing, so that the GSD is not manipulated. In addition, we are working right now on test concepts for security class 2 and security class 3, which means authentication and also encryption. But this is right now in definition phase. How to put this to the test tools, and the roadmap is not aligned right now. But we are doing the things. From specification point of view, everything is more or less inside, but now we have to specify how to test it, and also to have the resources to implement these things. And yeah, this is an ongoing topic now.
Okay, then I say thank you to Raik, and it goes to the other questions for Thomas. Thomas? Here we have the first question for you in the context of daily. The question was,
Yeah, I read it already. A gateway normally describes the Profinet to another field bus. It's a gateway. The serial is a converter. It's more a definition which comes up from HMS, but is covered from all others more or less in the same way. Sometimes it's also called gateway there. But this is just the naming. So for sure we have a gateway, which means from one protocol to another protocol, and what is quite new, it's so-called couplers. It means a gateway between the same protocol, Profinet to Profinet. It is normally called coupler in the wording. And the difference between a brand labeled product and a multi-identity devices is just if you have a brand labeled product, a fully custom brand label, then it's your device and you are the then it comes with your IDs, with your company IDs and all these stuff. Otherwise it comes from, it's a device from the provider, and there's the provider name and the provider ID and so on. That's the only difference between brand labels and standard devices. I hope this will answer your questions.
I think so. Okay, then the other questions. The second question, the last question currently.
I already answered this. What is the difference between brand labeled products?
Yeah.
Okay.
It's okay. This is the part when we look into the other monitor and the questions from the right side. Okay, this was the last question in the chat. And when you look up to the time, then we are on the end. Then let me open my last slide here for outro. And
actually, we have another question that just came in, but I don't know if maybe you want to answer it.
Behavior the test was not included to standard setup. It's a question for Reich, I think, and I'd say the Reich is the best reference for this answer, but Reich is not here. He has another webinar to the same time from now on, and we give the answer in the documentation. All your questions and all your answers we will write to the document, and the document will you can download after the webinar here in the next, I think, 2 days, 3 days, and all questions we will answer for you. By the way, here I make the closing session here, and the closing is here the information for you what we have. And here we have in the past Profi bus website, but in the meantime we have more as Profibus. We have Profinet and IO tools and many more. And so we have additional to Profinet to Profibus a new website here, the profinet.com site. Is in the future more specific for Profinet ecosystem and all what you need for this. And we will move in the future more and more Profinet specificas from the Profibus to the Profinet website. The other new site is a forum. A forum is makes for you. We have different areas with many experts from companies and from the PI organization, and you can ask your question in this forum, and normal responses time is within 1 day, and to the technology, to the profiles, to the implementation, or to the tests or certifications. we can give you an answer. The other thing is follow us in LinkedIn, in the newsletter, on the websites, and for Industry 4.0 or implementations, or come to our next workshops in persona here in Germany or in the United States, for example, or goes to the online workshops here, certification in June, or Profit Drive and Profit Save in March. And we have many more workshops and presenters workplaces. And you can also find us on the fairs here. The next one is Embedded World. 2 weeks later, we have Hannover Fair and also Achema or SPS. And then thanks here to the sponsors, thanks to the moderators, and thank you. Here again is the link to the slides. Additional after the meeting, the question, the answers. Additional here, the records from the meeting. And a wish from my side, we have here a feedback formula. Please click on the link or scan the barcode and fill it out. And for me, the important question is, which webinar would you like to attend in the future? Is this a webinar for SRCI or MTP or whatever? This is your my wish. Write it down, and we create a workshop only for this. Okay, then I say thank you to you, and have a good time, good day, good evening. Bye bye.